In this lesson, we will cover all the details of subnetting. And after this subnetting lesson, you'll be ready to solve all subnetting questions quickly. And if you are ready, let's go to learn what is subnetting. In IP address, we have two parts. The first part is network part and the other part is host part. And we have network bits and host bits. Here, our subnetting lesson is related with the host bits, and in this host bits, we will borrow some bits as subnet bits. What is subnet mask? A subnet mask is a value that is 32-bit long, and it has three notations. One of them is dotted decimal, it is generally used one, and the second one is binary, and the third one is with slash. Yes, here in the dotted decimal part, X represents decimal numbers from 0 to 255, and Y represents in the binary format 8-bit binary numbers from 0 and 1. Z represents how many ones are there. Here, for example, if we use 24 after slash, this means that we have 24 ones. And this means that 24 bits are network bits. Also, the zeros represents the host bits. Here are the examples of some subnet masks. The first one is dotted decimal, the second one is binary format, and the other one is slash format. What is IP subnetting? IP subnetting is basically dividing the network into smaller network groups. Here, our aim is using our IP addresses efficiently, IP version 4 addresses efficiently, and to do this, we use different subnet masks. There are two types of subnetting. One of them is classful fixed length subnetting, and the second one is classless variable length subnetting. We will see all the details of these lessons in the following slides. So, what is the benefits of subnetting? Why we use subnetting? First of all, it is used because it provides efficient IP address usage. As you know, there are very limited IP version 4 addresses, and they have also exhausted. To use the existing ones efficiently, we use subnetting. Especially using subnetting reduces the broadcast traffic, because when you divide your network into smaller parts, your broadcast traffic is reduced. And this also increases your performance, and it provides easy network management. Also, security is important for subnetting. When you divide your network into smaller parts, you can have different broadcast domains, different networks, so each network has its own security. Here are the classful IP addressing ranges. Class A, Class B, Class C, Class D, and Class E. Here, you can also see the default subnet mask for Class A, B, and C. These values are fixed for these classes. Here are the Class A addresses that we have also seen in IP addressing lesson. Class A is from 1.0.0.0 to 126 to 255, 255, and 255. And here the first and the last ones are reserved. And Class A has 126 networks. And this provides a lot of addresses in these networks. It is almost 16 million. And Class B addresses are here. And for Class B addresses, 16,184 networks. And here is also the addresses in each network. It is same. Class C addresses are here, and for Class C addresses, we have a lot of networks, almost 2 million networks, and in each network there are 256 addresses. So let's remember the IP distribution. Which organization does IP address distribution in networking, in network world? This is IANA. It is Internet Address Numbers Authority, and IANA distributes IP addresses to 5 regional internet registries of the world. These regional internet registries are RIPE NCC, ARIN, LACNIC, APNIC, and AFRINIC. These regional internet registries distribute Class A IP addresses to large companies. They distribute Class B addresses to medium companies and Class C addresses to small companies. Let's show the benefits of CIDR with different examples. Here, if you have a medium-sized company, you will have a Class B IP version 4 address. This company can use 16,384 addresses in this network. But it has 2,500 network devices or interfaces that requires IP address. How about the other IP addresses? All these IP addresses will be vested. Another example, if you have a small size company and you have a Class C IP version for address, your company can use 256 addresses in this network. But you have only 100 network devices or interfaces that requires IP addresses. What will be the other IP addresses? All of them will be vested. Another example about connecting two routers. For example, you have an IP block with /24. With this IP block, you will have 256 IP addresses available. The first address will be the network address. The last one will be the broadcast IP address, and you will use two interface IP addresses in the middle. So totally 4 IP addresses will be used. But what about the others? What about the other 252 IP addresses? They will be vested. And this is the point that CIDR comes and changes the rule of the full game. What is CIDR? CIDR is classless inter-domain routing. It is developed by IETF and it has improved IP allocation mechanisms. The main goal of CIDR is slow down the growth of routing tables on internet and slow down the exhaustion of IP version 4 addresses. Before we have talked about the Classful system, Classful IP addressing system, and as you remember, there were 5 different IP address classes. With CIDR, this mechanism is changing and it replaced this old Classful system. CIDR is based on VLSM and VLSM is variable length subnet masking. Here's a table and this table shows subnet masks, last octets and the CIDR notation with slash value and then the host bits and addresses, available addresses. For example, for the first one we have 255.255.255.0 and all the last octets are 0 here. So the CIDR notation is /24 and the available addresses will be 2 to the 8 is equal to 256 addresses. CIDR and VLSM. These are two terms used together, but there is a difference between these mechanisms. CIDR allows IP address usage without classes. It eliminates using classes. VLSM allows division of the networks using different subnet masks. CIDR is mainly used on service providers. VLSM is mainly used on small companies or networks. Now let's give some examples for different CIDR notations. CIDR /24. Here is an IP address and there is a subnet mask here for /24 and here. The first 24 bits are our network bits and the remaining 8 bits are host bits. 2 to the 8 is equal to 256 addresses. We have 256 available addresses for this IP address. When we subtract 2 from this value, we find the available host addresses, 254. Yes, here, as you can see, the first one is the network address and the last one is broadcast address. The network addresses, all host bits are zeros, and the broadcast addresses, all host bits are ones. And the addresses in the middle are host addresses. Another example, another CIDR example is /25. And here the first 25 bits are network bits and the remaining 7 bits are host bits. 2 to the 7 is equal to 128 addresses. And the available host addresses is 126. Another example is CIDR/26. Here we have 26 bits in network part and 6 bits in host part. 2 to the 6 is equal to 64 addresses. And if we subtract 2 from this 64, we find 62 available host addresses. Another example, /27, and here the first 27 bits are network bits and the remaining 5 bits are host bits. 2 to the 5 is equal to 32 addresses and available host addresses are 30 addresses. Let's give an example about address blocks. Here is an IP address and we will write this in binary format and the subnet mask, and we will also write this in binary format. Between these binary formats, we will use AND operation. And as you know, AND operation means that, for example, you have 0 and 0, then it is 0. If you have 1 and 0 or 0 and 1, it is 0. And if you have 1 and 1, it will result as 1. So, according to this AND operation, our value is here. And this is the network address of this block. Here all the host bits are zeros. But if we change these host bits from 0 to 1, then we will find the broadcast IP address. Let's see in one screen the network address, the broadcast address, and the available 254 host addresses. Another example here, and we have an IP address and the binary format of this IP address and /27 and the binary format of this value and AND operation. Yes, we have found the network address here. Let's talk about the last octet. If we use AND operation between 0 to 1, it will result in 0. 1 to 1, it will be 1. 0 to 1, it will result 0. 1 to 0, and all these ones will be 0 because these parts are 0. So this is network address, and when we change these host parts with ones, then we will find the broadcast IP address. Our broadcast IP address is here, the network address is here. Let's show this also in one screen. Network address, broadcast address, and the available 30 host addresses. Another example, we have an IP address, and this time our subnet mask is 255.255.192.0, and this is /18. When we use AND operation, we will find the network address again, and our network address is 192.168.0.0. And to find the broadcast IP address, again, we will change all host bits to ones. And this time, our broadcast IP address will be 192.198.63.255. This is our broadcast IP address. And below you can see the available host IP address range. There are also some special subnet masks. The first one is /32. It is used on loopback and system interfaces. Another one is /31. It is used on point-to-point links. And 30 is also used ISP networks for point-to-point connections. The last one is /24, and it is used in the local networks by default. These special subnet masks are very important. Subnetting example 1. Let's do an example with an IP prefix. Here, how can we divide this network into two subnets? Here we have a router and two switches are connected to this router. We have two networks and we will divide this prefix into two subnets that we will use on this network. Here, let's firstly write our IP address in binary format. For two subnets, we need one borrowed bit. Why we need one borrowed bit? Because we need two subnets and with 2 to the x, we need to reach 2. So with 2 to the x is equal to 2, x here is 1. So we need one borrowed bit. With one borrowed bit, we will have two different subnets. The first subnet will begin with 0 and the second will be 1. Here the network bits will be 25 bits and the host bits will be 7 bits. When we write this value in decimal format, it will be 100.100.0.0 and 100.100.0.128. Before, our address block was /24. Here we have one borrowed bit, so 24 plus 1 is equal to 25. Our CIDR notation will be 25. In host bits, there are 7 bits, so 2 to the 7, there will be 128 addresses and 126 host addresses will be available per subnet. Another example, we have 4 subnets here and we have this prefix. And how can we divide this network into 4 subnets? Let's write the IP address in binary format again. And here we need 4 subnets. To reach 4, we need 2 to the x is equal to 4. So what is x here? Here x is 2. This means that we need 2 borrowed bits. And when we borrow 2 bits, there will be 4 different options. 0, 0, 0, 1, 1, 0, and 1, 1. And the network bits are 26 bits and the host bits are 6 bits. When we write in decimal format, our network addresses are here. 150.30.10.0, 100.30.10.64, 150.30.10.128, 150.30.10.192. These are the network addresses of new subnets. Our first CIDR notation was 24. Now we have 2 borrowed bits, so the new CIDR notation will be /26. And 2 to the 6 is equal to 64 addresses, and these are the addresses that we can create with these numbers. But we need to subtract the network address and the broadcast address of each subnets, and after this subtraction, we will find the available host addresses per subnet. This is 62 host addresses. Yes guys, this is end of our lesson and it is time to test yourself. We will check that if you learned this lesson correctly or not. If you are ready, let's go. Question 1. How many bits are there in a subnet mask? An easy question for you, and I will not wait too much for this question. How many bits are there in a subnet mask? Yes, it is 32 bits. Question 2. How many usable host addresses are there with 255.255.255.192? How many usable host addresses for this subnet mask? Here are the choices. I'll give you some time for this question. Let me show you. I will write the first 3 octet in decimal format, and I will write the last octet in binary format. But to show you, I'll write with this one. To reach 192, we need to write here 1, because the value of this one is 128. 128. And this will be also 1 because the value of this part is 64. When we add this value to this, we will find 192. So the other ones will be 0. So these parts are network parts, and these parts are host parts. So we have 1, 2, 3, 4, 5, 6 host parts. So 2 to the 6 is equal to, oh, my pen is very crazy, 64 addresses. But it is asking usable host addresses. We need to subtract 2 because 1 for network address and 1 for broadcast address. So the usable host addresses are 62 addresses. Question 3. What is the CIDR notation of 255.255.224.0? Here are the answers. I'll give you again some time. I think it is also an easy question for you if you understood correctly this lesson. And here, let me show you again. I'll write the first octets in not binary format, but I'll write this one. Yes. And this is 0. I wrote only the third octet in binary format. To reach this one, this value, we need to write ones. Firstly, I write this one. The value of this part is 128. I write this one again, and the value of this is 64. And then I will write 1 for this, and this is 32. And when we add these ones together, then we will find 224. So these are zeros. For CIDR notation, we need to find these ones. There are 8 ones here, 8 ones here, 3 ones here. Let's add them, and the correct answer is 19. So the answer is /19. Have a 19. Slash, yes, it is very crazy. 19. Question 4. What is the broadcast address of 145.60.8.0/27? Here are the answers. I'll give you some time again. Let me write this number again, and I will write the last octet with this, like this. Here we have 32 minus 27, 5 host bits. So here are our host bits. And the other parts are our network parts. So the last octet is 0. It is easy, so we can write all zeros here. This is the block, but how can we find the broadcast address of this address? We need to change these zeros to ones. So we will change this 0 to 1, this one to 1, this one to 1, 1 and 1. So our new IP address will be 145.60.8. This is 31. When we add the values of these ones are 31, let's show how. This is 1. This is 2. This is 4. This is 8. And this is 16. So when we add these values, we will find 31. So our broadcast address will be this. Question 5. What is the network address for 55.8.90.5/28? Here are the answers, and I will give you some time. Let me write the address again, and I will write the last octet in binary format for you to show you better. Yes, the last octet is 5. To find 5, how can we write this last octet? So when we write 1, the value of this is 2 to the 0 is 1, because this is the 0th bit. This is 2 to the 1 is 2, but it is not for us. But here 2 to the 2 is 4, so I will write 1 here. To reach 5, we are doing some tricks. So all the other parts will be 0. So this is our CIDR value, and this means that we have 4 host bits. And these are network parts. And here it is asking network address. So in a network address, all these host parts are 0. So we will convert these ones to zeros. 0 and 0. So these are also coming as 0, 0. So our network address is 55.8.90.0. Our answer is B. Question 6. Which subnet mask is used for loopback interfaces? A, B, C, D, or E? For loopback interfaces and system interfaces. This is a piece of cake for you. I think you know the answer of this question, and it is A. 255.255.255.255. We have 120.15.0.0/24 prefix. If we would like to divide this prefix into 8 subnets, what will the new CIDR? Here are the answers. I'll give you some time again. Here we will find how many bits do we need to borrow from the host paths. So if we need 8 subnet, we need to find 2 to the x is equal to 8. So what is this x? This x is 3. So we need 3 borrowed bits. When we get 3 borrowed bits, we will add these 3 borrowed bits to 24 and the new CIDR value will be 27. Question 8. This is our last question. We have 90.4.0.0/24 prefix. If we would like to divide this prefix into 4 subnets, which one is not one of the subnets? Here are the answers and I will give you some time again. To divide this IP prefix into 4 subnet, we need to find this value. 2 to the x will be 4. So x here is 2. We need 2 borrowed bits. So after 2 borrowed bits, we will have a new CIDR value and this will 26. Let's also calculate the number of host bits. This is 32 minus 26 is equal to 6. So we need 6 host bits. 2 to the 6 is equal to 64 and this will be our addresses. So let's write one by one each subnet. The first subnet will be 0. The second one will be dot 64. The third one will be dot 128. The other one will be dot 192. There are 16 addresses between these network addresses. These are network addresses of each new subnet block. So, which one is outside of this group? This is outside of this group. So, our answer is C. Yes, guys, we have finished our subnetting lesson. I hope you like this lesson and the questions after this lesson. And if you like this video, this lesson, please do not forget to like it and subscribe to our channel. Good luck!